Today we're going to be talking about trapezoids and kites. So a different way of looking at a trapezoid is a triangle with the top cut off. Okay, so a lot of our properties that we used for triangles we're also going to use for trapezoids because they have a lot in common. So one thing that the trapezoid has to have is one pair of parallel sides. So we have to have one up here and one here. Now it could be turned sideways, but trapezoids have exactly one set of parallel sides, and those are called your bases. So what's on the side is called your legs, just like we did in triangles. We had the base and the legs. Here in trapezoids, we have two bases and then the two legs on the side. Okay, so base angles of a trapezoid are two consecutive angles whose common side is the base. Okay, so just like in a triangle, these would be our base angles down here. However, since we have two bases of the trapezoid, these are also base angles. All right, so if you have a trapezoid, look at this one down here. We have our two sets of parallel lines, but our two legs are congruent, then you're going to have, it's called an isosceles trapezoid, and your base angles are going to be congruent. So these two would be congruent up here, and these two would be congruent down here. Okay, moving on. All right, so let's move on to a trapezoid in a coordinate plane. If you have a quadrilateral in a coordinate plane and you're either asked to identify what type of quadrilateral it is, or they tell you it's a trapezoid and prove it, you can do that by proving the two bases are parallel. So how do you do that? You show that they have the same slope. So we would need to show that RS has the same slope here as OT. Okay, just slope formula, easy peasy. If you're trying to prove it's an isosceles trapezoid, then you would need to show that the legs are congruent. And here, obviously, they're not congruent. We can tell by looking. And it's not an isosceles trapezoid. All right, next. Let's see here. So many chords with this. Gets caught up. Let's see if I can get it to show the whole thing. Hold on. There we go. Okay, so now we have a few theorems to go with this. The first is isosceles trapezoid base angles theorem. It's literally the same thing that we just talked about. If a trapezoid is isosceles, then each pair of base angles is congruent. So how do we know it's isosceles? We have the two legs congruent, and we know it's a trapezoid because we have one set of parallel lines. Let me turn this light off so I can get rid of the glare, or at least down. Okay. Oh yeah, that's better. Okay. There is your isosceles trapezoid base angles theorem. The next theorem is the converse. Okay, so in the converse, if we have a trapezoid, and we know that we do because it's a four-sided figure with one set of parallel lines, and we see that the base angles are congruent, and it doesn't have to be these base angles, it could be these up here, okay? As long as it shows one set of base angles congruent, then we can say it's an isosceles trapezoid. So that's the converse. And the other identifying feature is that if the diagonals are congruent, then you have an isosceles trapezoid. So it's going to be isosceles if the diagonals are congruent, if the base angles are congruent, and or if the sides are congruent. All of those are identifying features. Okay, let's look at example 2 here. It says the stone above the arch in the diagram is an example or is an isosceles trapezoid. Find the measure of angle K, M, and J. All right. So if it's an isosceles trapezoid, what would the measure of angle K be? First of all, where are my bases? KL is a base, right? And JM is a base. Yes? So that means that LM here, this is a leg, and KJ, this is a leg. These are the legs, and these are the bases. So it tells us it's isosceles. Therefore, my base angles are going to be congruent. That means L and K have to be congruent. So the measure of angle K would be 85 degrees. Now, how can we find the measures of J and M? Well, we know all the angles have to add up to be what? 360. So I'm going to show you two different ways to do it. All the angles here have to add up to be 360. So you can multiply 85 times 2 and subtract that from 360. So what you have left is an angle measure or a degree measure that you're going to split evenly between these two angles here in the bottom. So you can take that answer and divide it by 2. Another way you can do it is because back in 2 sections ago, we learned that if you have a parallel, if you have parallel lines, then consecutive interior angles are supplementary, right? So this would be our transversal, so that we know that 85 and whatever angle M is are supplementary. And so you can figure it out that way. So it would be 95 down here. Okay, and then it says, let's see. What is step 3? Find J. Oh, J is the same as M, right? Because it's an isosceles trapezoid. So base angles would be congruent. All right, let's try another one. Okay, they tell us here that this is a trapezoid, and we've got parallel lines marked. That's all we have marked. Okay, so look at number 2. Number 2 says if EG, that's your blue diagonal, is equal to FH, your blue diagonal going this way, is the trapezoid isosceles. What do you think? If the diagonals are congruent, yes, it's isosceles. If measure of HEF, all right, this top base angle is 70, and the measure of FGH is 110, is a trapezoid isosceles. How would you solve that? We don't know that it's isosceles, but how could you solve it? We have this angle measure here and this one here. So you could say, all right, we have parallel lines, so we're going to use consecutive interior angles theorem to show that the measure of angle F here, the whole angle F, is 70. And once you've shown that those two angles are congruent, then you can say it's isosceles. All right, let's move on. There we go. Okay. All right, just like in triangles, when we had mid-segment theorem, we also have a mid-segment theorem with trapezoids. It's almost the exact same thing. But you can tell by looking that this mid-segment here is definitely not half of the base, right? There's no way that's half of the base. So what we do is, because we have two bases, we have one up here at the top and one down here at the bottom, we add them up, and the mid-segment is actually half of both of the bases added up. Other features of the mid-segment are still the same. The mid-segment is still parallel to both bases, and it still is at the midpoint of the legs. So you still have to find the midpoint of the legs, and so you have one side congruent to the other, and you have parallel lines. All that's still the same. So let's try one. Let's come over here. Let's see here. There we go. Okay, it says in this diagram, MN is the midsegment of trapezoid PQRS. Find MN. So we have 13.5 at the top and 18.5 at the bottom, 18.9 at the bottom. How would we solve for the mid-segment MN? Thoughts? Anybody new? Okay, add up your bases. What are our bases? Up here at the top, PQ. Here's a base, and here's a base. Add them up and divide by 2. Okay, so you should get 16.2 inches when you do that. All right, back over here. All right, so if we're going to find mid-segment in a coordinate plane, this is what you do. They've given us this trapezoid. First, we need to make sure it's a trapezoid, okay? So we're going to make sure that SB is parallel to TU, and we're going to do that by showing that the slope of SB is congruent to the slope of TU. After we know that it's a trapezoid, we're going to find where to draw the mid-segment. How do we know where to draw the mid-segment? Well, we need to find the midpoint of this line and mark it. That would be midpoint formula, right? X1 plus X2 divided by 2 and Y1 plus Y2 divided by 2. Use those coordinates, mark your midpoint. Do that for this side over here also. And notice that it doesn't land exactly on a grid line. So midpoint formula is definitely something that you probably should use to find these, even if you have a horizontal line. If it's exact, then that works. Otherwise, use midpoint formula. Mark your midpoint, draw your mid-segment. So your slope of YZ is also going to be parallel to SV and to TU. Now to find the length of your mid-segment, you're going to add up the length of your 2 bases. So use distance formula to find SV, use distance formula to find TU, add them together and divide by 2. So here they've done that for us. They got square root of 20 and square root of 80, both simplified. They added them together and see, look, when they both simplified, I don't know if you guys remember adding radicals, but you can add them when what's underneath the radical sign is the same. So they are going to take 1/2 or divided by 2 of 2 times square root of 5 plus 4 times square root of 5. So they end up with 6 times square root of 5, divide by 2, so they have 3 times square root of 5. Questions? Okay, let's move on. Moving on to kites. All right, so this is a kite, like the shape of the kite that you fly. And things you need to know about kites is it has 2 sets of congruent sides. So these 2 would be congruent and these 2 would be congruent. Just like some of our other quadrilaterals, the diagonals of a kite form perpendicular lines. It is not a perpendicular bisector. Look, it is not cutting it in half. Perpendicular lines. Okay. Kites also have exactly 1 pair of opposite angles that are congruent. So it's always going to be on your shorter side, it's going to be the opposites. So here C and A would be congruent. Obviously, by looking, B and D are not congruent. Okay, so let's move down here. Too far. All right, so let's look at this one. Example 5, they show us a kite. Okay, we have 73 degrees here and 115 degrees here. How would we find the measure of D and F? So first of all, they told us it's a kite, and we see that we have these sides marked congruent. So we know that D and F are going to be congruent, right? And this is a quadrilateral, so the whole thing is going to equal 360 degrees. So add up 73 and 15 and subtract it from 360. What you have left is going to be split equally between D and F, so just divide by 2. Here's another example right here. How do we find the measure of C and A? Add up 80 and 50, subtract them from 360. So that would be 360 minus 130, and then divide by 2. So measure of C would be 15. Almost done, guys. All right, let's look up here at monitoring progress number 6. Okay, it says in a kite, the measures of the angles are 3x, 75, 90, and 120. Find the value of x. So 3x is going to be equal to either 75, 90, or 120. How would you solve that? Ideas? This is what you do. Add up everything, set up your equation, making it equal to 360. So you have 3x plus 75 plus 90 plus 120 equals 360. Okay, so add them all up. Let's see here. 90, 75, and 120. All right, so we have 285 plus 3x equals 360. So subtract 285 from 360, and you get 75. Now you have 3x equals 75. So x equals 25. And if you were to draw that kite, let me get some paper. If you were to draw that kite, your big end, your biggest angle, which would be on the top of the kite, would be 120 degrees. 90 would be the one there on the bottom, and 75 would be your two across from each other that are equal. Okay, let's look at this diagram. So here at the top, we have all different types of quadrilaterals, right? So then all things that are trapezoids, let's start with kites. All things that are kites, there's only one. Only one thing can be a kite. It's got to have consecutive sides congruent, one pair of opposite angles, right? That's it. Kite can't fit into any other category of quadrilateral. Then we have trapezoids, okay? We have two different kinds. We have isosceles and we have non-isosceles. So here they are, and then we can break that down a little more into isosceles. Over here, we have parallelogram. Several different types of parallelograms. We have, this can be broken down into rectangle, which means that it has 4 right angles, right? Opposite sides congruent and parallel, and 4 right angles. The rectangle, we can break that down then into a square. All 4 sides congruent. The rhombus has opposite angles congruent and all 4 sides congruent. And then that can go down to a square also. All right, let's look at a couple more here. Actually, let's do these. Okay. Example 6 says, what is the most specific name for quadrilateral A, B, C, D? Okay. So let's look and see what we have. Do we have any sides marked congruent? No. Do we have any angles marked congruent? No. But we do have diagonals bisecting to form congruent sides. So what do we know about that? So we do know that the parallelogram diagonals converse says that those intersect to form congruent sides. They bisect each other. So parallelogram is our most specific name we can give for this one because we just don't have any information to classify it more from there. All right, let's look at 7, quadrilateral DEFG has at least one pair of opposite sides congruent. What types of quadrilaterals meet this condition? Okay, one set of opposite sides congruent, and we know that it's a quadrilateral. So what different types have at least one pair of opposite sides congruent? Parallelograms do, right? They have at least one. Rectangles have at least one. Rhombus has at least one. Square has at least one side opposite congruent. Could be a trapezoid. Trapezoids an isosceles trapezoid could have one set of opposite sides congruent. All those could meet it. All right, so look at 8. Give the most specific name for the quadrilateral. What do you think for 8? We have these two sides congruent and these two sides congruent. Any thoughts? So 8's going to be a kite. Consecutive sides congruent. How about 9? What do we have on 9? We have one set of parallel lines, and we have all different angle measures. 9's going to be a trapezoid. We have these two sides parallel. It's not an isosceles triangle because we don't have any markings that these are bisecting each other. And we don't have any markings that these are congruent. So just a trapezoid. And number 10, what do you think about number 10? On number 10, we have one set of opposite sides congruent. We have a value here, but we don't know how that goes with anything else. We show that one diagonal is bisecting the other, but we don't know anything about this diagonal. So for number 10, the most specific name you can actually say is quadrilateral. We just don't have enough information on that. Okay, so we're going to work through some assignments together. So go ahead and grab, or you can write on notebook paper. I'm going to pull it up on the screen, so you don't have to print it out unless you just want to. But there's 3 in-class assignments there that we're going to work through together, and then you can just upload them for your grade for today. And then there's a homework assignment online as usual. Also, before anyone has to leave, there is extra credit up. It's in bigideasmath.com. There's also a link to it on the Google Classroom. So it's extra credit, up to 10 points on your test next week. So I would consider doing that. And if you don't need 10 points on your test next week, then I will put the 10 points wherever you need them. All right, let me get my share screen up here.
Miss Herrera, I have to get going, but
Okay.
when do you want me to turn in the daily assignments?
Anytime before we come back to school is fine. So
Okay.
we're gonna walk through it together in the video. So if you just want to pull the video up later and walk through it, or you can just do it on your own, you might not even need the video.
Okay, I'll look at the video either later or tomorrow.
Okay.
Okay, thank you.
Have a great trip.
Thank you.
Bye. All right, so we're not going to do the top one for time's sake. But here we go. Let's start with the warm-up, 7.5. Okay, so what we have here are trapezoids, right? 2 different shapes of trapezoids. Both are trapezoids because they have one set of parallel lines. One set of parallel lines is bases. And there we go. I think I left for a minute. One set of parallel lines as bases, and then they have two legs. Okay. So it says use the diagram to determine the measure of the angle. So let's look here. Let's look and see what we have for this diagram right here. We have a 90-degree angle. We have something else that we don't know what it is. We have 60, and we have a linear pair right here of 1 and 2. So where do you want to start? Let's start with angle 2. All right, so if we have these two parallel lines, right, then we can say that angle 2 is congruent to 60, right? Alternate interior angles theorem. Yes? So then what does that make angle 1 if they are a linear pair? If this is 60, angle 1 is 120, right? They're a linear pair, they have to equal 180. Now we have another theorem, you have to think way back when, that says if you have parallel lines that are cut by a transversal, and the transversal is perpendicular to one of the two parallel lines, then it's perpendicular to the other one. So angle 3 is also 90. It's like called the perpendicular transversal theorem or something like that. If you can't remember that, you could say, okay, well, this is a quadrilateral, so it equals 360. And I know 1 is 120. And then here we have 60. And here we have 90. Add them all up and subtract from 360. You'll still get 90 right here. All right. Let's look at 4, 5, 6. Let's start with 5. Because right here we have a linear pair, don't we? So angle 5 plus this 45-degree angle have to equal 180. So you could just say 180 minus 45 gives you 135. So you know that angle 5 has to be 135. Now come down here to angle 4. Angle 4 is an alternate interior angle to this 45 degrees, right? We have parallel lines. Here's our transversal. So we can say angle 4 is also 45 degrees. Now to find angle 6, add up angle 5, angle 4, and 71, and you will be able to get angle 6. Subtract it from 360. Okay, let's look down here and review mid-segment of a triangle before we go do mid-segment of trapezoids. All right, so it tells us that MN here is a mid-segment of ABC. Find the values of X and Y. All right, well, we know that to draw a mid-segment, you have to find the midpoint of each side. So M is the midpoint of this line right here, which means this side and this side are congruent. So X must be 4. We also know that the mid-segment is half the value of the base, correct? So therefore, Y must be half of 11.
What was number 6 again?
Number 6, you need to add up angle 4, 5, and 6 and subtract, you need to add up angle 5, 4, and 71 and subtract from 360.
It's 109.
Okay, number 2, here's our mid-segment. They give us the value of 12. So we know that X must be double our mid-segment because it's our base. So our mid-segment here is half of our base. So that means x is what? 24, yes? How about y?
10.
Yes, how do you know it's 10? You're right. It's a little tricky. So 10 is also congruent to this right here. However, it shows us that these two are congruent, which means this must also be 10, which then makes y 10. All right, let's look at number 3. We have a right triangle here for number 3. So our mid-segment MN, and we know that M has to be the midpoint of AB. So our value of X is going to be 9, right? What's our value of Y? Any thoughts? How do we find Y? I'll give you a clue. It has to do with the fact that it's a right triangle. Remember that Pythagorean theorem? So if this is 9 here for X, that means this side is 18, right? So let 18 be our side A, and 34 can be our side B. And this side here is our side C. So we would say A squared plus B squared equals C squared. So we would say 18 squared plus 34 squared equals C squared. Let me do that on my calculator here. Y'all do it too. 18 squared Okay, then once you get your answer, take the square root of it, and that would be the length of AC. Then we don't need the whole length of AC, do we? We just need half of it. So divide by 2. What'd you get?
I got 19.23.
Good. Good job. Yes. All right. Let's do the one that says Geometry 7.5 EP. All right. Number 1 says show that the quadrilateral with vertices at Q, R, and S and T is trapezoid. Decide whether the trapezoid is isosceles. Then find the length of the midsegment of the trapezoid. That is a whole lot of stuff to do for number 1, okay? So let's start by plotting it. All right, while you guys are plotting that, I'm going to get a sheet of paper so we can work this together. Okay. All right. I am going to plug this back in so we can work stuff together here. Can you guys see my screen or no? Or is it blank?
We can see it.
We can see it. Okay. So let's see what happens when I do this. Maybe I have to stop share screen. There we go. All right. Let's go this way. All right, somebody read me the coordinates, please, because I had to take the thing off the paper. So, all right, what are my coordinates?
Zero.
0, 3.
0, 3, and what is that?
Q.
Q. Okay, now what?
0, 6.
Oh, nobody told me I was going the wrong way. Y'all. All right, 0, 3, 0, 6, 4, 5, 6. Okay, what is that point?
R.
Okay, what's next?
-6, 0.
And that one is,
S.
okay,
And then -3, 0. And that's T.
okay, 1, 2, 3, 4, 5. I put it in the wrong place. Good grief. 1, 2, 3, 4, 5, 6. Okay, so S and T. So they want to know if this is a trapezoid and if it is isosceles. Okay, so for a trapezoid, we only have to have what? One set of parallel lines, right? So we need to show that QT, here, that's weird that it's written like that. There we go. QT is parallel to RS. So let's find our slope
Hi.
of each. All right, so slope of RS and slope of TQ. All right, so for RS, we're going to have change in Y over change in X. So my Y value for R is what? What did we say, 6? Right? So 6 minus 0, and my X value is 0 minus, what is that, 6? So my slope is, did you get -1? All right, so let's do our slope of TQ or QT. So my Y value for Q is 3. My Y value for T is 0. And my X value for Q is 0. And my X value for T is -3. Okay, so that you show that your slopes are the same like this. And then you can say parallel. So this proves that it is a trapezoid. Okay, and then it asks us, let me toggle back. It asks us to decide whether the trapezoid is isosceles. Okay, how do we prove that it's isosceles? we have to prove that the legs are congruent, right? That would be the easiest thing to do. Otherwise, we would be trying to prove that these angles are congruent. So let's prove that the legs are congruent because we can do that easily with distance formula. So the distance of ST is going to be what? X1 or X2 minus X1, right? So our X values on S are -6 minus -3 squared plus our Y values. Well, that's 0. So the distance of ST is what? -3 squared. Yes, you can also count it because it is horizontal. We could count 1, 2, 3, and 1, 2, 3. But let's practice doing it this way because this is probably the only one you're going to have like this. Okay, so the distance of ST is 3. So now let's do the distance of RQ. Same thing. Whoops. All right, so X2 minus X1. So my X2 is 0, and my X1 is 0. And how about my Y2 minus Y1? We have 6 minus 3. So here we have the square root of 3 squared, which is square root of 9, which is 3. You don't even have to write the square root of 9 because if you square a square root, it just drops. Okay, so here, this shows that they are isosceles. And let's see, did it ask us anything else? Find the length of the mid segment. All right, length of the mid segment. Where would the mid segment go? If we were going to plot a mid segment, where would we put it? First, we have to find the midpoint of what? Our legs, right? We can't put a mid segment here. Can't put it here. It has to go from midpoint of leg to midpoint of leg. All right. So the length of ST is 3. So if we're looking for the mid segment of that, yes, we can do midpoint formula. And we can do x1 plus x2 divided by 2 and y1 plus y2 divided by 2. And in doing that, we're going to get right there, which would be 1, 2, 3, 4, -4.5, 0. And here we're going to get 1, 2, 3, 4, 5. We're going to get 4.5, 0. If you know the distance, you can take the distance, the length of the side, and divide it by 2, 1.5. Then you can start at one end and go over that distance. Okay, so if we connect this, now we need to find the length of that mid segment there. In order to do that, we have to know what the length of our bases are. So now we need to do a little bit more math. So to find the length of our bases, we're going to use the distance formula to find TQ. All right, so our X value of T is -3. And our X value of Q is 0. And our Y value of T is 0. And our our Y value of Q is 3. X2 minus X1 squared plus Y2 minus Y1 squared. You just need to pick which one is going to be your 2 and your 1 and just be consistent. So here we have negative 3 squared plus negative 3 squared. What happens when you square a negative? It's positive, right? So we have 9 plus 9. So we have the square root of 18. Can we simplify the square root of 18? Think back to algebra 1. How could we write that? We could say the square root of 9 times the square root of 2, right? Which then gives us the square root of 9 is 3 times the square root of 2. Okay, so let's now go do the other one. This is SR. So x2 minus x1. Here we started with t, so let's go ahead and start with s here. So we have negative 6 minus 0 squared plus our y2 is 0 minus 6 squared. This is going to give us negative 6 squared plus negative 6 squared, which is going to be the square root of 36 plus 36, which is what? The square root of 72. Okay. So how can we reduce or simplify the square root of 72? Thoughts? What can we do? We can do a couple things. Who remembers how to do this? We could say the square root of 9 times the square root of 8, right? We can break this up even more, right? We could say the square root of 9 times the square root of 4 times the square root of 2. If you want to go bigger, we could say the square root of 36 times the square root of 2. Then you can do it all in one step. Let's do this. So that simplifies down to the square root of 6 or 2 times, or sorry, 6 times the square root of 2. Okay, so now let's do our mid-segment formula. We have to add our bases and divide by 2. So here we have, come over here. We have 6 times the square root of 2 plus 3 times the square root of 2. And we're going to take half of that or divide it by 2. So what do we have? We have 9 times the square root of 2 divided by 2. You can leave it like this. You could say 4.5 times square root of 2. Either one's fine. All right, let's move on. That should have taken care of number 1.
Wait, can you leave that sheet up for a little bit? I'm not done finishing.
Yes.
Thank you.
Here. 4.5 square root of 2. All right.
All right, I'm done.
Okay. So let's see if I can share my screen with this camera plugged in. Let's see. Will it do it? It does. Oh, you can't see my screen, can you? You still see the work we just did, right? Okay, let me just unplug that. There's me. Now, how do I share my screen? Screen share. Okay, there we go. Can you see it? No, you can't see my screen, can you?
Yeah, we can.
You can? You can see this extra practice worksheet?
Yeah.
Okay, great. All right, so now let's look at number 2. Number 2 says in exercise 2 and 3, these are going to be way faster, by the way. Find the measure of angle K and the measure of angle L. Okay, so let's look at 2. We have parallel lines. And we have that MJ and KL are congruent. So what does that tell us about our base angles? They're also congruent. So on number 2, we have, even though it's at a weird angle and it doesn't look like it, we have an isosceles trapezoid. So the measure of angle L is also going to be 23 degrees. And you can find the measure of angle K and J in one of 2 ways. You can say that, for example, M and J are supplementary. So you can take 180 minus 23 and find J. Or you can say this whole thing is 360. I'm going to add up L and M, subtract from 360, and then divide by 2 for my remaining angles. Okay, let's look at number 3. Number 3 is a kite, and we know it's a kite because we have consecutive sides congruent, okay? So this angle here is 30, and this one over here is 90. And we know that with a kite, we have one set of opposite angles congruent. So we know L and K are going to be congruent. So add up 130 and 90, subtract them from 360.
$140.
Okay, so we have 140 degrees to split evenly between K and L. So divide by 2, and that's your answer for each of them. All right, let's look at number 4. On number 4, we have a trapezoid that is sideways, right? Because our bases are here on the side. So these are our legs right here. And it says find CD. So we have a midsegment. CD is the midsegment. And we know it's the midsegment because we have D as the midpoint here on this side with 2 congruent parts, and C is the midpoint on this side with 2 congruent parts. So our formula for finding CD is to add both of our bases, those are your parallel sides, and divide by 2. So add 12 and 36 and divide by 2, and that's the length of CD. All right, let's look at number 5. Now we're trying to find one of our bases. We're given one base and the midsegment, and we need to find the other base. So we know that this midsegment is half of these 2 bases added up. So to write our algebraic equation, we're going to say 1.8 equals 0.6 plus x all divided by 2. So 0.6 plus x in parentheses divided by 2. Or just put them both above the division thing. Now, what's my first step in solving this algebraically? I'm trying to get x by itself, so what do I need to do? Clear my fraction, right? So multiply both sides by 2 so you can clear that fraction. Then you should get 0.6 plus x equals 3.6. Then you can subtract 0.6 and get x, which is the length of CD. All right, let's look at number 6. In 6 and 7, find the value of x. Okay, so we need to set this up algebraically. So we know that 3x minus 2 equals x plus 11 plus 3x plus 3 all divided by 2. Do we need to do this one together maybe? Perhaps. Let's see. Okay. Let's try this one all together here. Nope, it's gonna attempt to focus again. Every time I take this camera off, it wants to refocus. There we go. Okay, so we have 3x minus 2 equals x plus 11 plus 3x plus 3 all divided by 2. Yes? All right, let's start by clearing our fraction. Multiply each side by 2. So now we have 6x minus 4. And let's go ahead and combine our like terms right now instead of having to rewrite it. So we have 4x plus 14. Now we're just going to solve algebraically. Easy enough? All right, let me see if I can change it there without having to unplug everything. Okay, now share the screen. Okay, so now can you guys see the assignment again, the paper, number 7? Yeah?
Yes.
Okay, so let's look at 7. How do we solve for x on this? Thoughts?
We say that they equal each other.
They do equal each other. So F and J are congruent to J and H, but these two obviously aren't. So we just set them up equal to each other, equal to each other. So we have 9 equals 1/10 x minus 1. So let's just do it algebraically now. Let's see, video, cover cam. Okay, so let's just do it algebraically now. Add 1. So now we have 10 is 1/10 x multiply by 10 to clear that fraction. 100 is x. Make sense? Okay. Now let's open the one that says practice A. Let's look at this. All right, it says in exercise 1 and 2, find the value of x. All right, what kind of figure do we have here? We have one set of parallel sides, right? So we have a trapezoid. And we have congruent legs. So we have an isosceles trapezoid. So this is 94, which means this is also 94. And these two are going to be congruent. So you can add up 94 and 94, subtract them from 360, and divide that number by 2 to get your angle measure, or you can say 94 and x are supplementary. So you can take 180, subtract 94 from it, and get x. All right, let's look at number 2. Number 2 here, we have a kite. We have a kite, and we know it's a kite because we have congruent sides, consecutive congruent sides, consecutive congruent sides. So what we know about this kite is that there is exactly one set of congruent angles, and they are opposite from each other. And we know it's not this because this here, x, is obviously not a right angle. So it has to be these two. So we know this is 100. So what's your missing angle measure for x? 100 plus 100 plus 90. Subtract it all from 360. What's left is your angle measure for x. Okay. So now on 3 and 4, we need to plot these. I'm just going to write them on my graph paper real quick. A is 0, 3. B, 4, 5. And C, 4, -2. And D is 0, -2. Okay. Okay, so let's plot these. So A is 0, 3. B is 4, 5. C is 4, -2. And D is 0, -2. Okay, and it says, the directions say, where are the directions? The directions say, find the length of the midsegment of the trapezoid with the given vertices. So we are looking for the length of the midsegment. So we have to figure out where to put the midsegment. So our parallel lines are going to be where? This one, right? And this one. And we can say that because they're both vertical lines. We don't actually need to calculate anything. So we need the midsegment. So here we have a horizontal line So we can actually very easily find the midpoint of this one by counting. So we have 1, 2, 3, 4. This right here is the midpoint. However, AB, not a horizontal line. What is the slope of AB? Just out of curiosity, it looks like it's 2, let's see, up 2 over 1, 2, 3, 4. So it looks like it's 1/2. All right, so let's find the midpoint of AB. So our midpoint formula says x1 plus x2 divided by 2. So we're going to say 0 plus 4 divided by 2 and 3 plus 5 divided by 2. So our midpoint coordinates are going to be 2, 4. So let's go there. 1, 2, 1, 2, 3, 4. So right here. So we're going to draw our mid segment. Now we need to find the length of our mid segment. So our coordinates here were 2, 4, and our coordinates right here are, oops, not 0, are 2, -2. All right, and how do we find the length of the mid-segment? We use distance formula. So we're going to use these coordinates when using distance formula because we're asking for the length of this mid-segment here. It's a vertical line, so we actually don't need to use distance formula. But if it wasn't a vertical line, we would. So let's count boxes. 1, 2, 3, 4, 5, 6. So your length is 6. Excuse me. All right, let's go check the next one here. Okay, the next one says we're going to do the same thing. We have something else to plot. All right, let me erase this. Should have brought home a lot of these sheets. Go ahead and start plotting. You don't need to wait on me. Okay. All right. Okay. So we have E is -3, 3. F is 1, 3. G is 3, -3. And H is -5, -3. Okay. Would it be helpful if I had a straight edge? Yes, it would. Okay. A little off there. Okay. All right. And we need the mid segment. So we need the midpoint of EH and FG. So let's start with EH. Let's find the midpoint. So my coordinates for E were -3, 3. And my coordinates for H are -5, 3. Okay, so our midpoint formula here is going to be -3 plus -5 divided by 2. And 3 That is negative 3 plus, right? Yes. Negative 3 divided by 2. All right. So these, I have negative 8 divided by 2, so I have negative 4, and I have 0. So negative 4, 0. 1, 2, 3, 4, right there. And how about here for FG? It is also going to be right here on the 0. And you can tell that it is because your X and Y values are going to be the same. So we need the length of this midsegment. 1, 2, 3, 4, 5, 6. Also 6. All right, let's take a look now. Go back here. Turn this off. Whoops. Turned off the wrong thing. Oh my goodness. Okay, so now let's look at 5 and 6. 5 says give the most specific name for the quadrilateral. All right, so let's look at number 5. We have parallel lines, one set of parallel lines. We don't have 2 sets, so that knocks out parallelogram. We have one set of base angles congruent. So what can we say about number 5? Isosceles trapezoid, right? For that, all we need is one set of base angles congruent, or a set of side or a set of legs congruent, and one pair of opposite sides parallel. All right, let's look at 6. On 6, we have consecutive sides marked congruent. Right here and right here. Congruent, congruent, and congruent, congruent. And we have one set of opposite sides congruent. So this one is actually a kite.
What was number 5? I didn't.
Number 5 is an isosceles trapezoid because you have one set of parallel sides and you have one set of base angles congruent.
Thank you.
Sure. All right, let's look at 7. 7 says describe and correct the error in finding the most specific name for the quadrilateral. All right. This says, excuse me, hold on. Oh, this says the quadrilateral has 2 pairs of consecutive congruent sides and the diagonals are perpendicular, so the quadrilateral is kite. Okay, but what we see here is that we have 4 sides congruent and perpendicular diagonals. So what is this figure actually? Not a kite, but a rhombus. It's a rhombus. All right, let's talk through number 8. You don't have to write it in proof form, but I want you to write down the steps that we would use to prove this, okay? It says A, B, C, D is a parallelogram. All right, they told us it's a parallelogram. That means AD is parallel to BC and congruent to it, and AB is parallel and congruent to CD. Also, our opposite angles are congruent. And then it says AE is congruent to AD, and they've given that. And now they say, prove that ABCE is an isosceles trapezoid. Okay, so what we would say, our number one basically would say that AD is congruent to BC, and that is definition of a parallelogram, right? Opposite sides are parallel and congruent.
Wait, so what's the answer for that one? Sorry.
We're just going through the different steps. So the first step would be to say that AD is congruent to BC, and that's the definition of a parallelogram, because our opposite sides are congruent and parallel. Step two would be to say that AE is congruent to BC. +1 if you can tell me why AE is congruent to BC. If you can give me the right reason. Any takers? All right, thinking all the way back to chapter 2. This is actually transitive property. If AE is congruent to AD and AD is congruent to BC, then AE is congruent to BC. You don't have to write all that. Just write AE is congruent to BC, transitive property. Okay, so now we have proven that the legs are congruent. Now we have to prove that AB and EC are parallel, okay? So to do that, we know that AB is parallel to DC because it's a parallelogram, right? Okay, so your step 3, we have to add this in there. So your step 3 is going to say ED plus DC equals EC. Who remembers what that's called? +1 if you remember. Chapter 1, ED plus DC equals EC. It's a postulate. Any takers? Three, two, one. Okay, segment addition postulate. So now we've said that EC includes DC, okay? Segment addition postulate. And then we can say AB is parallel to EC. That is also transitive, because if AB is parallel to DC, then it is also parallel to the whole thing. And our last would be to say that ABCD is a parallelogram. I'm sorry, ABCE is an isosceles trapezoid. I was looking at the wrong thing. ABCE is an isosceles trapezoid And we can use any number of those theorems. Let's see. Let's use, which one should we use? Let's use the isosceles. Actually, nope. We're going to use the definition of isosceles trapezoid. We're not going to use a theorem. Definition of isosceles trapezoid. All right, let's look at number 9. The figure shows a window in the shape of a kite. Find the measure of angle XVW. All right, we're looking for this angle right here. What is it? You don't even need to calculate anything. What is this angle? Who knows?
90 degrees.
90. Good job. It's 90. And now it says find XY. What is XY here?
22.
22 degrees.
22 inches. Good job. Which angle is congruent to X, Y, Z? Which angle is congruent to this one right here?
XWZ.
XWZ. Great job. And that is it. We are finished. So upload this into Google Classroom. The homework is on Big Idea.